Lesson 27. Find volume of composite figures. In this lesson, we will use the formula for volume and use addition to find the total volume of a composite figure, like the one on the screen. So let's take a look at this. So let's start at the beginning. If you've already checked out lessons 24, 25, and 26, you know that the formula for volume is length. Oops, it's in white for some reason. Is length times width times height. And that's only of a rectangular prism. There's a different volume formula for every kind of shape. What we have in front of us right now is kind of two rectangular prisms stuck together. And so what we're going to have to do is kind of unstick them with our pencils. The best way I can explain it is by cutting the figure in a way that makes the most sense. So we're not going to cut it in a funny way like this, because that doesn't give us a rectangular prism. That gives us another problem to do. So we're going to keep the line that we use to cut it really straight. We're going to keep it in a way that it's going to give us a length, a width, and a height of a new rectangle. So we could either cut it this way or this way. The thing is, you have to choose one. So pick one and go with it. I think I really like the idea of cutting the 8 up more than the 10. So I'm going to do that. And I'm going to cut this figure. And because I'm cutting up the 8, I'm actually going to circle it and remind myself it's not 8 anymore. Okay? It's not 8. It's going to be something else now, because some of it's going to be in this part of the figure, and I'm going to call this section A, and some of it's going to be in section B. Well, if I cut up the 8, well, what's going to happen to section A? Section A already actually has a length down here, and we can actually steal it from up here. They kind of already gave it away, that this section is already a 3. So box A already has a 10 for the height. We're going to put that in the height section. And it has a 3 for its length. So what is the width? Well, the entire figure shares the same width. And you're going to see that really, really often, that they share the same width. Because this is 2 feet, which means this is 2 feet, which means this is 2 feet, and this is 2 feet. So that means everything here has the width of 2 feet. So you can steal the 2 feet from down there. Okay. And there you have all 3, length, width, and height of section A. Now here's where things can get a little tricky. We've done section A. We know that the total down here was 8. We knew that because we crossed it out. Well, if this side is 3 and the whole thing was 8, what must this side be? If I take 3 away from 8, what do I get? That's right, I should get 5. So section B actually has a length of 5, a width of 2, and a height. How tall is section B? Is it 10 feet tall like section A? No, it's only 4 feet tall. And there we have 2 sections, and they actually make sense. That 8 feet, we didn't get to use the number 8 because we broke it apart. So section A is 3 times 2 times 10. Well, this is 6 times 10, which is 60 units, feet cubed. And let's go over here to B. 5 times 2 is 10, times 4 is 40. So if section A has a volume of 60 feet cubed and B has a volume of 40 feet cubed, what is the total? And that's a nice math action word. What is the total if I put 60 and 40 together? 60 and 40 should get us, let's see, that would give us 10. So that should be 100 feet cubed. So there is our volume of a composite figure. So composite is a fancy way of saying we pushed some stuff together. That's what it means. We pushed A and B together, now you have to figure it out. So we separated them. We decided how to separate it by using just a nice straight line and cutting a number. We crossed out the 8 because that's what we split up. We didn't want that to be used anymore. We found the volume of A by using what was already on the screen. A really was already on the screen. And then for B, we had to do a little bit of detective work and figure out what that missing length must have been if we cut the 8. Okay, so one of them, you're always going to have one of them where you're going to need to do a little bit of detective work, but it should be pretty simple. It should be some form of addition maybe. So let's try another one. So here we have another figure, and again, we're not going to cut this in a weird way like that. We're going to keep it really simple for ourselves. So we have two options here. We can either cut the 10 feet, or we can cut the 8 feet. I think I want to cut the 8 feet again. I don't know why. I'm just going to choose to do that. I'm going to cut the 8 feet. And I'm going to label the top A and the bottom B. And we're going to do the same thing where we're going to just try to figure out what the length, width, and height are. So for A, what is the length of A? Well, the total length is given to you. It's 10 feet long. What is the width of A? So how far back into space does it go? And we're always going to find that one. I feel like it's always going to be in this little bitty corner down here for some reason. So here's the width here, so that would be the width up here as well. So that's 1. And what is the height of A? How tall is A? Well, it's not on this side, so it must be on this side. It's 3 feet. And there we have length, width, and height for A. Let's try and figure out B. Let's figure that out. What is the length of B? Well, we knew the length of A. It was 10 feet. But B is not that long. As you can see right here, it's not nearly as long. It seems to be missing this section over here. So what is 4 taken away from 10? If 10 was the total and 4 is missing, how long is section B? 10 minus 4 is 6. So we subtracted that away. Because it's not existing. It doesn't exist there. It doesn't exist. What is the width of B? It's right here. The width is probably the easiest thing to find. It's going to be the same. So the width is 1, because that's how far back the picture goes. And then what is the height of B? Well, the height of A was 3 feet. And the total height for this entire thing right here was 8. So take off A, which was 3 feet. And how much did section B get? Right, it should be 5. So section B got a height of 5 feet. Oops. So by taking one step at a time, I'm able to find the length, width, and height of both sections. And now I'm ready to find the volume of those sections. 10 times 1 times 3 is 30. 6 times 1 is 6. 6 times 5 is 30. So what is the total volume of figure X? Because that's the name of the whole thing. 30 plus 30 is 60. So this is 60 feet cubed. All right, and we'll do one last example. Okay. So we have figure A, and let's figure out a way to cut this up. We have two options. We can cut it up this way, or we can cut it up this way. I think I would like to cut up the 10 this time. So I'm going to cut up the 10. If you do it another way, that's fine, as long as it makes sense. So I cut the 10, I circle my 10 and tell myself, don't use it anymore, it's not 10 anymore. I'm going to leave this section to be A, and I'm going to put this as section B, just so I can organize my thinking. So A needs a length, width, and a height. What is the length of A? Ooh, I'm not given it. I don't have it here on any of my lines showing how long it is. Well, I did have the 10, didn't I? I had 10, but I cut it. I wonder what the length of B is. So this line matches this line and this line. There it is. It's 5. So the section B has 5. That means I'm going to take 5 away from 10. And I get 5 as well. Okay, so they're equal. So section A has a length of 5. And I did that using some detective work and trying to figure out what happened if I took 5 inches away from the 10 down there. What is the width of section A? So how far back does it go into the distance? It's usually that diagonal line. And here's my diagonal line right here. And that's 3. And what is the height? How tall is section A? How tall is it? 6 inches. And there you have it. Length, width, and height. Just like that. Let's do the same thing for B. Well, we already figured out just from having to figure out A that B has a length of 5 as well. What's the width? Like I said before, that width is going to be shared with these figures, because the width came from over here, and you can see how all of these lines are pretty much the same. They are the same thing. And how tall is B? B is pretty short compared to A. So how tall is B? It is 2 inches tall. Now we're ready to solve part A and part B and put them together. All right. We have 5 times 3 times 6. So I'm going to need to do some serious multiplication. Let's see. I have 5 times 3 is 15. And I can multiply that by 6. 5 times 6 is 30. Composed of 3, 6 plus 3 is 9. So A has a volume of 90 inches cubed. That does not look like a 3. And I'm going to do, again, it's going to be 5 times 3 times 2 this time, so 15 times 2. 2 times 1 is 2, plus 1 more is 3, so that's 30. So section B has a volume of 30 inches cubed. Well, I want to know what the total for all of box A. So the whole thing. Remember, this was called just figure A at the beginning. So what is the total volume? What's 90 plus 30? 0 and 12 inches cubed. And there you have it. So finding the volume of composite figures is a lot of just remembering that you're going to be crossing something out and using some detective work, some detective skills to figure out how one dimension or one measurement relates to another. And always make sure that you're cutting up your shape into shapes that are easier to work with, not harder. Okay? This has been lesson 27, find volume of composite figures. In this lesson, we used the formula for volume, and we used addition to find the total volume of a composite figure.